Hello, welcome to the Chemistry Medicine series. Today we're going to answer one important question. Why do chemists use the mole or Avogadro's number? As we talked about last time, Avogadro's number, 6.02 times 10 to the 23rd, is a huge number. But why do chemists need such a huge number? The answer begins with atoms. As we know, atoms are incredibly small. In fact, even billions of atoms are too small to see and weigh on the laboratory balance. Because they are so tiny, their masses are not measured in grams. Instead, we use a much smaller unit called atomic mass unit, or AMU. By definition, 1 AMU is 1.66 times 10 to the negative 24th gram. This is an extremely small mass. So here is a challenge. Chemists need a way to connect the microscopic world of atoms to the macroscopic world that we can actually see, weigh, and work with in the laboratory. This is where the mole comes in. A mole is defined as 6.02 times 10 to the 23rd particles, which is also Avogadro's number. The mole is a bridge between the two worlds. Now we can see clearly on the left side, we have the macroscopic world of atoms, molecules, and ions, while on the right side, we have the macroscopic world of grams and the laboratory measurements. In the middle, the mole, the connection or the bridge between the two worlds. The reason we use Avogadro's number is that by multiplying the mass of a single atom by this number can give us a measurable amount of matter that we can actually see, weigh, and work with in the laboratory. Now the question is, we have so many large numbers. Why we choose Avogadro's number? To answer this question, let's take a look at one beautiful relationship. For example, a single carbon atom weighs 12 AMU. Now, let's do some calculations based on dimensional analysis. And here, we multiply the atomic mass for carbon, which is 12 AMU over one carbon atom by the atomic mass unit conversion factor, which is 1.66 times 10 to the negative 24th gram over 1 AMU. In this case, we can cancel out AMU to give us the gram over one carbon atom, which is also the mass of one carbon atom in grams, a very small number. Then we multiply this number by Avogadro's number conversion factor, which is 6.02 times 10 to the 23rd carbon atoms over 1 mole carbon. Then we can cancel out the carbon atoms to give us the new unit, grams per moles of carbon atoms. This is also the molar mass. Finally, we do the calculations on the numbers. We can end up with 12 grams over 1 mole carbon. Here, we converted the atomic mass to molar mass. For carbon, we can see the atomic mass and the molar mass, they have the same number, 12, but different units. This is not a coincidence. Because of Avogadro's number, the atomic mass and molar mass of the same element have the same numerical value. This only works with Avogadro's number, not with other numbers. This beautiful relationship makes chemistry calculations much easier and also helps us connect individual atoms to measurable amounts of matter. In the next video, we're gonna learn how to use the mole or Avogadro's number in the chemical calculations. Please follow Chemicell for chemistry that really makes sense. Thank you.